Let's solve such a problem. So, there is a race, 1 kilometer race, and runner 1 on track 1 run this 1 kilometer for this time 2 minutes 35.15 seconds. And as a result, he actually won the race. He appeared to be faster than the runner 2, and we know the time of the runner 2. And runner number 2 only 0.3 seconds um, has bigger time than the first one runner. Okay. However, length L2 slightly greater than length L1. We need to find how large can be line track number 2. Length of track number 2 could be longer than length of track number 1, so that we consider the runner number 1 is faster. Okay, let's draw. We have such a it's okay. Now we make a first track. This is such a track. It's like stadium. So this is our first track. This is inner track. And here is another track for runner number 2. Okay, let's mark it. This is first track, this is second track. Yeah, let's also from this side. This is L1 and this is L2. Runner 1, he runs on this track 1. And runner 2 on this outer track, and the length of outer track could be a little more than the length of track number 1, and as a result the runner 2 he should run a longer distance, and as we can see that the runner number 2 he has bigger time. He comes second after runner number 1, but he comes second because he's running not so fast, because he's slower, or maybe he comes second just because he should run the longer distance. And we need to clarify this picture and to understand and to answer the question. How large could be the track number 2 than the track number 1, for we can still consider the runner number 1 is a winner, that he is faster. Okay, let's write our data. What we have? We have time with which runner number 1 made this distance, run this distance. It's 2 minutes and 35.15 seconds. Let's present it in seconds. 2 minutes, it's 120 seconds. So, and this is 125.15 seconds. It's a time of runner number 1, how he runs this distance on a competition. Okay, as well we know the time of a runner number 2. It's 2 minutes. 2 minutes. 35 decimal 45 seconds. Okay, let's express it in seconds. It's 155 decimal 45 seconds. So the difference between them only 0.3 seconds. Not that big. For a distance of 1 kilometer, and they were running 2.5 minutes roughly. Yeah? And the difference between them is just third of a second. So they come to the finish almost together. Runner 1 a little bit ahead, but is it ahead because he's faster, or he's ahead because the runner 2 should run a bigger distance? No. If runner 1 won the competition only because he's running in an inner circle, in a shorter circle, so it's unfair, So, and we should clarify and to show and to understand what's going on here. Okay, they gave us that the race is 1 kilometer race, but they didn't clarify. 1 kilometer, it's a length of track number 1 or track number 2. If they didn't say it to us, we should make an assumptions because the difference in time very, very small, and when we will count this difference between the lengths of the tracks, we should everything, all data, take very precisely, because this very small difference, and so we should count with a high level of precision. Okay, we suppose that length of track number 1 is 1 kilometer. So it's 1000 meters. And the question is, how much longer could be track number 2 for we could consider that runner number 1 is faster. So we know the length, the distance, so to say, which our runner number 1 run through. Yeah, we know the distance, we know the time. What we can find? We can easily find his speed. When we say that runner 1 and runner 2, who of them is faster? When we say who is faster, what do we mean? What we compare? We compare speed. If runner 1 faster, it means that runner 1 has bigger speed. And now we can find speed of runner number 1. So speed of runner 1 is the distance he made divided by time he spent on this. We know the distance, it's 1000 meters. We have very clear number. And we know the time. It's 155.15 seconds. Here is meters. Here is seconds. And in answer we get meters per second speed. Okay, now we're taking our beautiful calculator and we divide 1000 divide by 155.15 equals 6.445 meters per second. Okay, let's we agree that we will count our physical quantities. We will consider till the third digit after a point. This is important to agree because, as I said before, this difference is quite small and we should be very careful with all the quantities and with all the numbers. So let's we agree that we will consider all quantities to the third digit after the point. Okay, now we know the speed the runner number 1 had. This is not just a speed in a certain moment of his running. This is an average speed. This is the average speed of all his race. Because with the whole distance divided on the whole time. So this is we don't need. Okay. And we have a question. How much longer could be this track number 2 than the track number 1, for we could consider the runner number 1 faster than runner number 2. Let's say, as we say before, why we consider the runner 1 faster. When we say it, we mean that he has a bigger speed, and we know his speed. And we agreed that we will consider all quantities and speed to the third digit after a point. So if runner number 2 has speed, let's say 6.445, can we say that number 1 faster than runner number 2? No, we can't, because they have the same speed. They're equally fast. If the runner number 2 has speed 6.446 meters per second, what does it mean? It means that runner number 2 faster than runner number 1. He has bigger speed, a little bit, but bigger. So it's not the case. And so the maximum speed of runner number 1, with which we still consider the runner number 1 faster, it's 6.444 meters per second. So 1000th part, so it's third digit after the point, less than speed of a runner number 1. If this runner number 2 has speed 1000th part more, then the speed will be equal. So this is the maximum speed which runner number one can have, for we could consider the runner number one is to be faster, to be a fair winner. Okay, so we know this maximum allowed speed for the number two runner, maximum allowed speed for him, for we could consider this runner the fair winner, the fair champion. So if we know this his speed, maximum speed we consider, yeah? And we know the time he was running, so we can find the distance he could cover in this time running with this speed. Okay, let's do this. L2 equals speed 2 multiplied time 2. So maximum speed of runner number 2, this is the speed, multiply, and we know the time which he was running, 155 decimal 45 equals. Now we are taking our absolutely beautiful calculator and we count. So 6 and decimal 444 multiply 155 decimal 45 equals 1001 decimal and what after point 7198 7198 meters. So, and we agreed with you that we count all quantities till the third number after a point. So we present it like this: 1001. So we round this to a bigger side, so it's 72 meter. And this is if the length of the track number 2. So what is the difference? L2 negative L1. We found that difference 1 meter and 72 centimeter. So what does it mean? What this answer means? That if the length of the track number 2 bigger than the length of a track number 1 on a number more than that, let's say 2 meters, we cannot consider the runner number 1 faster than runner number 2. But if the difference in length between these two tracks less than this number, then the runner number 1 is a fair winner of the competition. So if the difference in length bigger than this 1 meter 72 centimeters, so the runner number 2 actually can complain because it's not fair. Yeah, he can apply somewhere to special chord for